Light of wavelength 500 nanometer is incident on a metal with work function 2.28 electron volt. The de Broglie wavelength of emitted electron is. Since light incident on metal and electrons emitted, we have to find their de Broglie wavelength. First of all, we have to find the kinetic energy of emitted photoelectron. Now, I am using Einstein's photoelectric effect, equation of photoelectric effect, which says that kinetic energy of fastest electron is equal to the difference of energy of photon and work function. In the question, wavelength of electron is given in nanometer, which can be converted into angstrom. So I am going to use formula 12,400 upon 5,000. So my answer will be directly in electron volt, and the work function in the question is given 2.28 electron volt. On solving it, I get 0.2 electron volt. The kinetic energy of fastest electron is 0.2 electron volt. Now I am going to find its de Broglie wavelength. Since de Broglie wavelength of electron is 12.27 upon under root V angstrom, I am placing the value of potential difference. If kinetic energy of an electron is 0.2 electron volt, then accelerated voltage will be 0.2 volt. 0.2 volt angstrom. On solving it, I get 2.8 into 10 raised to power minus 9 meter. Now I have to check the options. The option number 1 is 2.8 into 10 raised to power minus 12 meter, that is wrong. Option number 2, 2.8 into 10 raised to power minus 10 meter, that is also wrong. But in option number 3, it is given 2.8 into 10 raised to power minus 9 meter, and fourth option is also given 2.8 into 10 raised to power minus 9 meter. So I have to check which option is correct. I have found the de Broglie wavelength of the fastest electron. I know that emitted electron have kinetic energy between 0 to a maximum value, and I have found the de Broglie wavelength of the fastest electron, which will be minimum wavelength among the electrons, because lambda related with kinetic energy, lambda equals to h upon under root 2me, means lambda inversely proportional to under root of kinetic energy. If kinetic energy is maximum, then wavelength will be minimum. So I can say that 2.8 into 10 raised to power minus 9 meter is the wavelength of fastest electron. But it is not given in the question that we have to find the wavelength of fastest electron. So the emitted electron may have kinetic energy in range 0 to a maximum value. So I can say that the kinetic energy of the electron may be less than 0.2 electron volt or equal to 0.2 electron volt. So the wavelength will be either 2.8 into 10 raised to power minus 9 meter or more than this value. So it is given in option number 4. So option number 4 is correct.